Start streaming. Is it recording? Oh, okay, it looks like it's recording. Uh, yeah, it's recording na. Okay. I just have to send the link. Uh, yeah. So yeah, I was saying, so okay, here's some basic principles of FreeCAD. When you select something, the task tells you what options you can do uh, with it. So when I select body, if I select padding, I see the sorry. Ayun, cancel. Ayan, padding. Sorry. If I select thickness, it will show me the task. Tama ba? Oh, it should be that. Anyway, well, that's what I thought it was. Ang weird kasi that's how it was. Like parang if I select this, the tasks that appear are relevant to the thing. But no, it isn't. Okay, mali yung pag I had misunderstood it. It seemed like it last time. Anyway, so yeah, you were modifying it with move and then it crashed basically. This was the cabinet,
Yes po, sir.
the entire cabinet.
Yes po.
Okay. Yeah, it would crash because it's recalculating everything. Tama ba?
Opo, ganun po nga po ata nangyayari.
So that means, okay, if we're going to remove an A2 plus assembled piece of furniture, dapat iba yung strategy. Okay, for research na lang. For research,
Sige po, sir.
for research na lang yung how we're gonna do that. Okay, let me stop sharing. Okay, Ivan, you can present your training material for today.
Okay, sir. Let me share my screen. Okay. So for this session, I'm gonna be showing you the complete workflow. Complete workflow on how we can work on an assembly connected to a spreadsheet. So this time, so as I've demonstrated during the past few meetings, so you've noticed that if we adjust something on the spreadsheet and then we refresh the corresponding changes to the assembly, there's an error. So this time I'm going to be showing you the workflow as to how we can avoid those errors. So in this session, uh, I'm going to be creating a simple cabinet. So with three major parts. So let's get started. So in this case, again, we create a new file and then we go to the part design. And then we create body and then we create sketch. So in this case, I want to work on the front plane. So I'm going to be choosing the XZ plane. Okay, so I guess this is the most important part of this session. So if you remember when when I was demonstrating during the past few meetings, we always set the origin point at the center of our object. For example, if we create a rectangle here, we always see to it that it's situated at the middle. But if you're just making a simple object, or let's say you're just making a single object, so this is fine. But then when you're dealing with assembly with different parts, and considering that you have to do such changes at the end, so it's very important to consider this origin point. So if you want if you want our object to be adjusted in the assembly using the spreadsheet, we need to set our origin point at the corner of the object, or let's say at the far end of the object. So in this case, if I'm gonna make the body of the cabinet, this origin point to be our I want this origin point to be our corner. Okay. And then let's say we want this one to be 1500 millimeters, and then this one to be 500 millimeters. Then we close it, and then we we pad it. Okay. So let's say we want this to be 500 millimeters wide. Okay. So if we go back to our origin, again, you can see the origin by just clicking the space bar. So so if we go in the front view, we can see that let's say we want our pad, make sure that your pad is in reverse, because so let's say we uncheck the reverse. So as you can see, our original sketch is already here. So if we want to sketch on the original surface, in this case, we need to check the reverse, because in this surface of the uh, object, we still need to sketch. We still need to sketch. Okay, so make sure that the reverse is checked, and we click OK. And then we can hide the planes. And then we want to draw a sketch for the uh, hole or the pocket of this cabinet. So again, don't forget to use your external geometries. And then I want this vertical distance to be, let's say, 400. And then the corresponding vertical and horizontal constraints, this should be 50, then this should be 50 as well. So on the other side, we also need to adjust the horizontal constraint. So 50. So we don't need to adjust our vertical of 50 here. So of the object. So I'm gonna explain it later why I've done this. So click close, and then we pocket it. Let's say we want to pack this at 450 millimeters. Click OK. Okay, so since in this session, the main objective is just to show you the workflow as to how we can perfectly adjust values on our spreadsheet to our assembly. So I'm just gonna be putting here a simple contact surface of a cabinet door. So I'm not gonna be doing door hinges for the so that we can save time. Okay. Uh, Again, I want to sketch on this surface. I'm gonna click sketch. And again, as you can see, our origin point is still here at the lower left.
Mm.
Okay, so again, don't forget your external geometry. And in this case, I just want a small contact surface. Let's say I want to create a 50 by 50 square or pad. And then let's say we want this cabinet to have 3 doors.
Mm.
Okay, and then let's set this to be 50, and then 50 as well. So since this is 1,500 in length, then we can set the distances between them at 450 each. So we can set this as 450. This one is also 450. We click close and then we pad it at 5 millimeters. Okay,
Mm.
we can leave it at that. So also we want to put contact points for the stand of our cabinet. So again, we go to the bottom and then we create sketch. As for the stand, we just need to create 4 boxes. We want this to be 50. Then this one is also 50. Okay. This one is also 50. And then we can just make this 4 as equal. This also, we can make this equal. And then we can set the vertical, let's say this one, let's say 100. And then for the horizontal, we want this to be 250. Then we can just use the vertical constraint to align these 2 boxes. We can select 2 points between them. And then let's just okay, let's put external geometry here. Let's just specify the vertical constraint 100. Then same thing here, you can just align this to by using the horizontal constraint. So in this case, we just need to specify our horizontal constraint to be 250. And again, we can align these two. And then we also need to set a vertical distance of this is 100. Okay. And then we pad it with the dimension of, let's say, 5. Okay, and then let's save this one. We want to name this cabinet underscore body. Okay, and then after the cabinet body, we need to create the doors. So again, we create a new file, and then we create body, and then we create sketch. Again, I want to work on the front plane, so I'm gonna be choosing the XZ plane. So as for the door, uh, again, it's very important that our origin point must be at the corner. So let's say we want to sketch our door like this. And then we set a dimension of 500. And then 500. Then we close it and then we pad it. We want to make this 30. Okay. So as you can see, so now I'm going to explain why we put the uh, origin point at the corner. So let's say, so in this case, since we've already situated our object's origin point at the corner. So let's say if you want to adjust the height of this object, let's say the original dimension is 500. So let's say you want to make this 800. So if that's the case, the adjustments will be at the opposite end. So since the origin point is situated here, the additional 300 millimeters that we added will be added here at the other side. So I'm gonna show that to you later in the assembly part. So again, we can hide this one. And then on the front view, let's say I want to create a small handle. So as you can see, our origin point is still here, but I want to work on the front plane. I want to work on the front plane and then our external. Okay, we forgot something. So we can go back to our pad. So, and then we can go back to our pad. So as I've said earlier, it's important that we reverse our pad. Okay, it's important that we reverse our pad so that we can sketch on this front surface. So if we uncheck the reverse, as you can see, our front surface is at the rear end of the object. This one, this is our sketch. And then it extruded on from right to left. But then if you reverse it, the extrude or the padding worked from left to right. So in this case, our left, this is our front view, and this is where we need to sketch. So we click reverse and then we click OK. Then we can hide this. Then we go back to our sketch. So as you can see, the origin point is here again on the front. So I think we just need to create a small circle here. And then let's say we want this to be 50. And then this one is 50 as well. Click close and then we pocket it at 10. And lastly, we want to create the identical contact surface on this. So we need to put this on the rear end. We just need to go to the rear. Then we sketch here. We sketch here. Okay, now we're at the rear. So again, external geometry. And then we just want to create a 50 by 50 contact surface. 50 and then 50. Goes and then we add this to 5. So I think our door is okay. Then we save this and then we want to name this as uh, cabinet underscore door. Okay, and then the last part, the stand. Again, we create a new file and then body and then sketch. And then again, I want to work on the XZ plane. So again, I'm gonna be putting my origin at the corner. So specifically, I want to put this on the upper left of my object because I want the adjustments to be made on the lower part of the stand. Okay, we want this to be 50 and the vertical distance, we can make this 500 for the meantime. Oh, 550, okay, you click close, we pad it at 50 as well. And then let's say we want to fillet this edges. We fillet it at, let's say 15. Okay, I think this should be good. We save this. We want this cabinet underscore stand. Okay, so after we create all these objects, now it's time for us to connect it to a spreadsheet. So I'm gonna go back here, the cabinet underscore body. Then I want to create a spreadsheet. We want the very basic, the length, the width, and then the height. And as far as I can remember, the length is 1500. The width is 500. And then the height is also 500. And you need to set an alias. We want this as length, width, then height. Then we go back to our original sketch. So we want this to be spreadsheet.length. We want this to be spreadsheet.height. Okay, and then we go back to our pad. We want this to be spreadsheet.width. Okay, now we're done with the spreadsheet of the body. Next, for the cabinet door, again, we create a new spreadsheet. The length, width, height. Then length is 500, the width is 30, and the height is 500. Length, so we need to set an alias again. Length, width, and then height. Then we can go back to our original sketch. This is spreadsheet.length. Spreadsheet.length. Spreadsheet.height. Okay. Spreadsheet.height. And then we can go back to our pad.
Ivan, sorry.
Ah, yes, sir.
Yung yung spreadsheet, point out that that spreadsheet, the name of that is because the name of the spreadsheet is spreadsheet. If you change that name, uh,
Okay.
you can change that name kasi 'di ba you might have multiple spreadsheets later on. So
Yes, sir.
FYI lang guys, it's called spreadsheet because yan, pakita mo yung spreadsheet sa ilalim because that's named spreadsheet.
Yes, sir.
Otherwise, if you change that name, it will change the x dot length, x dot height.
Yes, sir. It will correspond to the function. Like we change it as spreadsheet.door, and then if you use that on the function, then we need to use the same name for that.
Yeah. Correct. Yun. I just need FYI lang so that yeah, people
Yes, sir.
don't get confused. Okay, continue please. Sorry. Thanks.
Okay, sir. Then for the last spreadsheet, we okay. Now we're done with the cabinet door, and then lastly for the stand. Okay, create new. We want the length, width, height, and then the length is I guess 50 by 50 by height is 500. The length, set an alias length, width, and then height. And then we go back to our original sketch. So as Sir Justin mentioned a while ago, so let's say if we change the name of this spreadsheet into, let's say, spreadsheet.stand here in the property editor, so we need to use that name here in the formula editor or in the function. So we need to make it as spreadsheet underscore stand dot length, width, or height. So But in this case, I'm going to be using the default one, the spreadsheet, that this is the length. This one is the height. Spreadsheet that, oh, spreadsheet that height. Then you go to back to our pad, spreadsheet that width. Okay. Okay, now we're done with all the spreadsheets. Now let's proceed to the assembly part. Again, we create new, and then we go to the A2 plus. So again, before you work on the A2 plus, make sure that you save the file first. Save at cabinet underscore assembly. Okay, so we need to import our parts. So the first one is cabinet underscore body. Next is cabinet underscore door. So we want three of this. Door. Okay. So let's join this two first. So the very straightforward way to combine this is just to select these two surfaces and use the center of mass constraint. So in this case, I'm going to be using these lines because it's hard to select the surface. I want this to be on the same axis. And then I want these two lines to be on the same axis. Except,
Nice.
and then I guess we can select these two surfaces and then center of mass again.
Mm.
Okay, so now what if we, okay, I forgot to stand. Stand, let's make this 4. Okay, and then we can just simply join these two by center of mass.
Mm. Nice.
Okay, and then for the last peg, okay. Okay, so now we're already done with our cabinet. So what if we want some changes here? So we can go, let's say we want this cabinet body at, let's say 2000 millimeters. So we want this to be at 2000 millimeters. So before you can see changes on the assembly, make sure that you save this first.
Mm.
Each time you change something here in the spreadsheet, make sure to click save first. And then you can go back to your assembly. And then for you to see the corresponding changes, you just need to select this update parts imported into the assembly icon. So as you can see, it adjusted on the right portion of the table. Why?
Mm.
So it's because, so as you can remember, when we're dealing with the sketch of this cabinet body, we've set our origin point here at the lower left. So as I've said earlier, when we're dealing with adjustments in the assembly or in the part design, the changes will be added on the opposite side. So since I've set my origin at the lower left, so the additional 500 millimeters that I've added to the original dimension was added on the right portion of our object. So as you can see, there's a there's an additional space here. So
Mm.
if this is the case, let's say when this is if this is a real project. So you can just simply add an additional door if you
Mm,
uh, add, let's say, 500 millimeters here, just like our example, and then you can just add an additional door, so it will fit perfectly since our door is also 500 millimeters.
tama, tama. That uh call this, if it was a 2D thing, you'd have to redraw the entire thing. You'd have to redraw the entire thing. You'd have to, in the new drawing, you'd have to add a door. You'd have to adjust the legs, so you'd have to move the legs to another position. If it was a CAD drawing, diba? A 2D CAD drawing. But here, you just need to attach another door and make another external geometry
Contact
square,
surface.
right?
Yes, sir.
Contact, yeah. So you just need to make another external geometry, which you can do by editing the main cabinet.
Yes,
Uh,
sir.
so, so in theory, that reduces the amount of rework whenever we have to do revisions.
Yes, sir.
Uh, so okay. Sorry. Is Daisy? Yeah, Denzel, Daisy, what's your feedback on this? Um, it has some limitations, right? Certain shapes we can easily modify, but some of basic shapes we can easily use this. What do you think for the plant? Jason, nakita mo? Jason, were you able to see it?
About sir.
Ah, okay. So, but this is just this is just first we're going to refine this. Gagawa tayo ng mas maganda. We're going to make a better one. Call this. Alyssa is going to be tasked to make a more elaborate uh, um, one. Yung that way, pag modify natin, when we change it, when we modify it. Sorry, nagsiswitch ako to English and Tagalog because of the other people watch this video. so so when we modify the furniture, now we just use the spreadsheet if it's a basic simple modification. If it's a more complicated modification, we only need to modify uh, the main cabinet body and add a new component or remove a component. So that's what is the advantage of this system. This system, all our drawings are more reusable. Our products are more reusable. Um, yeah, ayun. Okay. So, anyone has any questions? Ivan, I have a question.
Yes, sir.
Is this how SolidWorks also does? It also has an assembly and auto calculation.
Sir, as far as I can remember, when I worked with SolidWorks, so SolidWorks, sir, it automatically updates when you edit
Mm,
something on, ano, on a specific part of an assembly. As far as I can remember, sir, parang may lumalabas na dialog box to just click OK, and then it will automatically, update.
For okay, but yeah, this is good. I mean, given for that it's a free open source software, it's like it's call this. We also explored using LibreCAD, which is purely 2D, but uh, I come from multimedia arts, and now the trend is like Pixar and all the other stuff. They're creating 3D assets because 3D assets have more reuse life, and the workflow for modifying 3D assets is becoming easier and easier every year. So so they create 3D assets in most, like in animation, in 3D modeling, in architectural visualization, and they just modify it, slightly modify it, and thus you don't have to redo the drawing again and again and again and again. Uh, so okay, so okay, so this is very promising. Thanks, Ivan, for the demonstration. Um, call this Alyssa. You had a working origin point methodology. The second one, is it?
Yes po, sir.
Are you free to demonstrate it lang? Yung with a simple box, one of the files that you created.
Check ko po, sir. Na-realize ko kasi yung parang na-move yung origin point niya, pero yung sa transform, hindi pala siya na ano. So, feel ko may na-miss akong step dun sa tutorial.
Okay, it's okay. It's just
Ah.
it's just to check lang. If it's not yet ready, it's okay. Anyway, we're gonna check on it again.
Sige po, sir. Ayusin ko na lang po siya.
Yeah, I think yeah, even if we just, I think most likely we'll be using Sketcher, and we will yung workflow from going back from the padded or the object from the body level to the sketcher level to the sketch level. Baka maybe that will be the workflow that we have to refine, so that people don't get lost. Um, and maybe the methodology, when do you use upper corner, like positive y positive x, or when do you use lower corner, negative y positive x, when is it when choosing where to set an origin, maybe that's where we can create training material about, because I think it's different per part. Like maybe for doors it might be a different uh, origin point. For legs, it might be a different origin point. For a body, would be a different origin point. And I guess creating a tutorial or training material based on based on these parameters, yung thesis natin, that will be helpful for when people start learning FreeCAD. Where they set the origin point. Ayun. Ayun. Okay. Sige, if that's the case, I guess, other questions, no? Call this Ray, the NU ME guys. Do you have any problems with FreeCAD right now? Uh,
Sir,
um,
none so far po.
yeah. Yeah. Was I able to share you the one the what you call this, the mechanical, the design of Ivan, of the mechanical, of the varnishing area?
Not yet po, sir.
Okay, I'll share that. Wait, I'm trying to remember what I'm trying to remember where I uploaded it. Okay, I think it's here. I think I put it in the OJT. Did I put it in the OJT? Did I put it in the FreeCAD folder? Most probably I put it in the FreeCAD folder. Yeah, it's here. I think it's here. Cabinet, CSC varnishing, as built draft, the dated November 22, right? Okay, copy. So here's the file. Tell me if you're able to open it or access it. I think I made. I'll double check if it's. Yeah, it's anyone can open. It's not confidential. There's nothing secret about the way our varnishing area works. It's just simple HVAC science. Call this. Tell me na lang. Can you tell me if it works, if you have access to the file, and if you can
Yes
open
po,
it?
sir.
Can you
Accessible naman po.
can you download and open it to see if there's any errors?
Okay po. We'll check po.
Yeah, just that way we're just sure. Let's call this. Let me just open it here. Varnishing as built draft, and then entire window. Okay. Okay. So one before we end, Ivan, was it clear the instructions of Sir Ray uh, um, about the change, the plans for the varnishing?
Yes, sir. To make it sure, sir, I'll just rewatch the meeting.
Okay. Okay. I sent you the link of the meeting. Do you have it?
Yes, sir, but I have a backup recording here.
Okay, good, good, good. That's very good. That's very good. Then in that case, call this. Remember, so I told Romel to train you how to create ducting plans, how to create the bill of materials for ducting. So Chris and stuff, and we'll have a separate arrangement. I'll still compensate you for that. And I consider it a separate arrangement. The creating the bill of materials. So remember, as discussed, all you have to do is make the bill of. First, let's draw the ducting plan. Let's do it in 3D. So it's visual, so that all people can see what's gonna happen to it. And then that's when after that, we begin the bill of materials. But during the part we're visualizing it, it doesn't. I think it's okay for you to have some of the training for creating ducting from Sir Romel and Chris. Since they're both ME, and of course our plant manager Ray is also ME. So I think they can comment. So I guess after this internship you'll have some bonus skill set because they'll show you how. If you're still available, one of the things I'm thinking about getting is the Papa research ko if you're still available. If you're available, the metal sheet one here. Which one is it? Have you seen that one? Is it no, it's not. There's a metal sheet works bench for folding metal sheets. It's specifically the way it's designed. It's actually perfect for us because we have benders and turret machines. So it's the basically the workbench that tells the machine how to fold steel sheets for ducting, for piping, for shapes, for boxes. Is it this one? No, it's airplane design. I'll try to find it anyway. So if you're ever if you're still available after Christmas, call this. I might get you for that research. Kasi anyway, if you're going to be an ME guy, you'll be doing ducts. Diba? Tama ba? Kyle, what's call this? Kyle Ray, you guys will also be made to design ducting, right?
Yes po.
So, an app, learning to use an app. Sorry, hindi nagsho-show yung ano. Sorry, stop sharing. Entire screen. So one of the apps here is designed for metal sheets. So if you learn to use it, it should make it easier for you to create bending and turret machine plants, so that CNC devices can. I'm not sure. I think it's also exportable to CNC devices. CNC machine. So learning this would also be beneficial to you guys since you guys are eventually going to make ducts, and most steel sheeting is ducting, other than some cabinetry and data cabinets. That's one of the most common metal sheeting uses. Yeah, that's pretty much the most common metal sheeting uses in our industry. Wala siya dito. Sheet. I know maybe it's under sheet. Sheet metal. There it is. Yeah, it's the name of the sheet metal. So that will be a separate thing. So yeah, I don't know if you've seen it. Joko Engineering had a demo about sheet metal. I know that I watched. That's where I got my assumptions about how it's used. But I don't do ducts, so I don't know how to do ducts. So yeah, let me check. I can install it, right? Yeah. Anyway, so that's all. Anyone have any questions with the Ivan's presentation? Do you need the files? Do you guys need the files? Any of the files are needed? Okay. I assume you don't need it. So yeah. Okay. Call this because it's kind of complicated. I'm not gonna ask people to do it because Ivan kasi is very practiced. Okay, so this concludes our session, our training sessions. If ever we're gonna have another training session like this. Alyssa, you would be the one taking the lead.
Sige po, sir.
Okay. So this is probably after Christmas na. Okay.
Yes po, sir.
Okay. So there. So yeah, thanks Ivan. I'll still be seeing Ivan for other projects, but this is the last training session from Ivan for this period. For this period naman, since Christmas, it's already going to be Christmas. It's going to be December next week, and all I think all the NU students have all these obligations to perform. Tama ba? Is it correct? All the
Yes,
trimester students. Okay. Yeah, tama. Okay, sige. So we can conclude, guys. If you have no other questions, we can end the session.
Thank you, sir.
Okay,
Thank
thank
you
you. Thank you, Ivan. Thank you, everybody.
Thank you, sir.
Okay.
Ivan.
Yeah. So Jason, kung may kailangan ka kay Ivan, sabihin mo lang. Ako mag-handle. Okay. Okay. And end session. End stream.